All right, now we are going to go through your assignment for organic chem. So if you turn to the notes and you go to the back of the book, you should be able to find your organic chem assignment. We start with assignment J1. All right. Okay, I'll be going through every question with you so that you can follow. Okay, first question. Which of the following pairs are members of the same homologous series? So the idea of homologous series is that they must have the same functional group. And usually they have the same general formula. And they tend to be different by maybe some CH2 unit. So we will look at functional group. That's the easiest. So if you look at this is an alcohol. This is an aldehyde. So therefore it cannot be, right? So number 2, this is an alcohol. And this is an alcohol. So what we can see that is different is that this seems to be a longer alcohol. So likely this is going to be the answer, but we will check the rest. This is a ketone, and this is an acid. So again, different functional group, and this is a ketone, and this is an aldehyde. Can recognize them? So therefore, answer is B for question 1. Question 2, what is the IUPAC name of this? So one look at this, you must know the functional group. COO, so it's an ester. So for ester, to name it, we must cut along the COO. Cut it up. And you will have to name the alcohol part first, then followed by the acid part. So the alcohol part has 3 carbon. The acid part has 1 carbon. So 3 carbon, we call it prop. And 1 carbon is met. So it's propyl metanoate. O8 is the name for an ester. Next, which compound has the lowest boiling point? Now, to look at boiling point, we have to look at the intermolecular force that you learn hydrogen bond, dipole, and also LDF, right? So we can see here there's an OH, so it's hydrogen bond. We can see OH, hydrogen bond. Hydrogen bond is one of the strongest intermolecular force. So therefore, it's unlikely for them to have a lowest boiling point. So then we are left with these two. They are basically non-polar compounds. Why do we say that they are non-polar? Because C and H bonds are non-polar. So if we draw out C, it looks like this. CH3, 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 CH3. If we draw out D, it will be like this. CH3, CH2, repeat 3 times, and CH3. So the difference is this is a straight chain, and this is branch. So branching tends to weaken the London dispersion force, whereas straight chain has a larger surface area. So as a result of the larger surface area, it has a stronger London dispersion force. So therefore, the lowest is C, which is a branch hydrocarbon. Next, these are skeletal structure, but you can see what is common is they have the same molecular formula, C5H12. So in terms of electron cloud size, they have the same electron cloud. Okay, so what is difference is that we can see this is straight and these two are branch. And among the branches, this is more heavily branched, and so it has the lowest, smallest surface area. And as a result, it will have the weakest London dispersion force. So it must be the lowest one, right? We must start from lowest to highest. So therefore 3, then 2, then 1. Answer is C. Okay, next question. You are supposed to find out structural isomers. So to first know what are structural isomers, they must have the same molecular formula. So we can always check first, do they even have the same molecular formula? So this one will be total number of C be 1, 3, 1. So C5, H, 6, 7, 8, 9, 10, 12. Okay, C5, H, 12. Then you do the same for the rest. So you can see 1, 2, 3, 4, C4, H. 3 times 2, 6. 6 plus 4, 10. This one, 1, 2, 3, 4, 5, C5. Then, 5. Then 7, so 12. So you can see number 2 don't even have the same molecular formula. So definitely cannot be structural isomers. Okay, so it's number 1 and 3. So what's the difference is that number 1 is straight chain, where number 2, there is a branch of a CH3. So number 3, right, looks like this, CH3, CH, CH3, CH2, CH3. So there's a branch like this, okay? Okay, next one. What is an amide? So amide, to recognize, it has a functional group that's C double bond N. Right, so we look up for C double bond N in the amide. So the first one, we are seeing COO, which is an ester. Second, we are seeing CON, which is what we want, CON. That's an amide. So the first one is an ester, second one is an amide, and so while we still continue, the third one is an amine. There's an N, but don't have the CO. And the last one, you have an acid, you have an amine, so it's an amino acid. So answer is B. Okay, next, which is a propyl propanoate. From the name O8, O8 means ester, ester. So we're looking for ester that has 3 on each side. Prop is 3, prop is 3. So cut up the ester where the COO is, cut it up, okay? And this is not even an ester, this is a CO, not COO, so it's a ketone. And this is an O, not even a COO, so it's an ether. So out of this, let's count carbon number 1, 2, 3. 1, 2, 3, correct. How about the next one? 1, 2. 1, 2, 3, 4. So wrong. So answer is A. Question 8. We are supposed to identify some functional groups that we can see here. So what can we see? Of course, we can see a benzene. So those with benzene, correct. Okay, we can see a ketone. This is CCOC. CCOC. So this is a ketone. I can see ketone, not aldehyde. Aldehyde is COH. So aldehyde is COH, not COC. And I can also see an amine. I don't see double bond O. I see C single bond with N. No C double bond O. So it's amine, not amide. So with that, answer is A. Okay? I do not see alkene in the structure at all. So therefore, those options with alkenes are wrong. Okay, classify alcohol, we circle them. I's on the carbon, which has the OH. I's on the carbon with OH, not on any carbon. So I's on the carbon with OH and circle 1 group, 2 group, 3 group. So out of the 3 group, all of them are alkyl, so will be tertiary. I's on the carbon, 1 group, 2 group, 3 group. Out of the 3 group, only 1 alkyl, primary. I's on the carbon with the OH, not on any other carbon, 1, 2, and 3. So out of the 3 groups, 2 alkyls, secondary. So tertiary, primary, secondary. Answer is B. All right. Okay, now let's look at the structured question. They say example of homologous series is alcohol. So what some of the features? So we have gone through just now. Homologous series feature is that they must have the same functional group, or therefore same chemical properties. And they have something same. They have the similar, same general formula, not empirical formula, general formula. That means the CnH2n plus 2 CnH2n. Okay, and they, the features is they differ in physical properties. Why do they have different physical properties? Because of the increasing CH2 length. So they have different physical properties due to increasing CH2 unit. Okay, so that will be something like that. That's for question 1. Describe 2 features. So I gave you 3 of a homologous series. Okay, question B. There's a lot of things happening here. There's a lot of reaction. We're supposed to name the structure only. Okay, but besides naming, maybe I'll just very briefly go through what are the reactions. So what's happening here is I have an alcohol, and it's with an acid, and I get something COO. So this is an ester. So it's an esterification reaction, making ester. Next, I have an alcohol. I get with a CHO. CHO is an aldehyde. Okay, and the reaction is oxidation. We have not covered this in class yet. Then the aldehyde becomes an acid COOH, which is an oxidation. Again, we have not covered the reaction in class. Okay, but anyway, what is important is just to name it for this question. So we just try to name it. So for those who cannot see, you may need to draw out better. Okay, then you can see better. So I'm going to draw out D for you. So it's CH3. This is D, CH3, CH. See, there's 2 CH3. So one of them must be here. So I've drawn until here already. I've drawn until this part. Then continue drawing a CH2, a CH2, a CH2. So a CH2, a CH2, a CH2, and an OH. Okay, so with this, that's the D. So try to name it. Longest continuous carbon chain is this. Alcohol must be given 1, smallest number. So therefore, this is carbon 1, 2, 3, 4. At number 4, there's a methyl. So it's called 4-methyl. Remember, this is a substituent. And it's carbon 1, 2, 3, 4. Okay, 4-methyl pentan 1-ol. Must tell people where is the alcohol. So 4-methyl pentan 1-ol. Okay, if it goes on to oxidize to form an aldehyde, so the penta 1-ol will become an aldehyde. So again, this will be carbon number 1, 2, 3, 4. And number 4, you will still have a methyl group, but instead of a pentan 1-ol, it's now a pentanal. No need to tell me it's penta 1-nal because aldehyde is by default always 1. Understand? So no need to say, oh, penta 1-nal. It's always 1. Then for the aldehyde, now it became an acid. Acid is also always at 1. So again, the main thing remains just the aldehyde side changes. So for methyl pentanoic acid. No need to tell me penta-1-oic acid is pentanoic acid. Okay, now next we are going to look at the last one, which is the ester. To name an ester, you have to cut. You don't have a choice. So cut it up at the COO. Find the COO, cut it up. So here is the alcohol. Here is the acid. So it's a 2-carbon acid with our main alcohol 4-methyl pentan 1-ol. Right? But we cannot call it 4-methyl pentan 1-ol. So we call it 4-methyl pentyl. The alcohol side is named as an alka. So and with L. Okay? And then the acid part, there are 2 carbons, so ethanoate. Ethanoate. OATE. Instead of ethanoic acid is ethanoate, OH. So it's an ester. Okay? So we have finished naming D, E, F, G. Now we are going to look at the structures of the boiling points here. So there are some pentane here. So you can see same molecular formula, but that the melting point are different. One of them is a boiling point, one of them is 10, one of them is 28, one of them is 36, and we're supposed to assign the boiling points to the isomers. So you can see that this is a straight chain. So it has the largest surface area. And therefore, it should have the strongest London dispersion force. So we assign 36 to it. The more extensive the branching appears, like in C, then the lower the surface area and the weaker the London dispersion force. So it has the smallest area, and therefore we assign 10 degrees. And then the intermediate one will be the 28 degrees. Okay, so we got a boiling point and we need to give us our reason. So what we can see is that B and C are branch. Okay, and C is more branch than B. So therefore it results in smaller surface area. So the keyword I must see is surface area and branch. So a smaller surface area and therefore it has a weaker London dispersion force. So less energy required to boil. So the lowest, less energy required, so lowest boiling point. And so on. So roughly we get the idea. We must use the word branch. We must see the word surface area and therefore link back to London dispersion force and the boiling point. Okay, so now try to name B. The longest carbon chain of B is comprising of 4 carbon over here. Okay, and this is a substituent. For C, the longest carbon chain is 3 with 2 substituents, 1, 2. So if we name B, it will be smallest number to the substituent now since there's no functional group in the chain. So 1, 2. So it will be 2-methyl butane. Okay, and then for C will be number 2, there are 2 groups. So 2, 2, dimethyl. Yeah, propane. Okay, it comes from propane. So roughly that's the idea for assignment J2. J1. Okay, then next assignment J2, we will be looking at some of the free radical substitution and the calculation. So I will do the MCQ only for J2. Okay, so there is not too much. So let's look at just J2 MCQ. So you can turn to J2 to look at the MCQ first. Okay, ready? So now we are at J2. We will be doing the MCQ question. Now, this is more like the reaction of alkenes. Now, we are looking at free radical substitution. They say which reaction occurs via free radical substitution. So you need to associate this to alkene. So once you associate this to alkane, then it's easier. Look for an alkene, right? So the first one is an alkane. So it's likely to be the free radical substitution where the H is substituted with a bromine. But we still look at the rest. So number 2 is an alkene. Alkene is associated to electrophilic addition reaction. So you add to the alkene. Number 3 is an iodine there. So it's a halogenoalkene. and halogenol alkane is related to this reaction called nucleophilic substitution. We have already covered that in class. Okay. Is related to nucleophilic substitution. And number 4 is something that is a bit different. We have a halogenol alkane substituted with water. It is also a halogenol alkane. So it is also nucleophilic substitution, where the Cl is substituted by a nucleophile. And the nucleophile can be OH, can be water. Okay? Substitution. Okay. Next, which of the following will be present at the chlorination of methane? So again, this is the free radical substitution reaction. Okay, free radical substitution. So we may have a chlorinated methane where one of the H is substituted. We may have multiple substitution whereby more than one H is substituted. We can also have the alkyl radical, which in this case is the methyl radical reacting with another methyl radical in the termination steps. And we will get a longer hydrocarbon, ethane. Okay, now we will also get HCl in the first propagation step. If you remember, the first propagation step is something like this, Cl dot plus CH4 arrow. So it will break one of the CH bond to form a HCl with it. So you form HCl plus a methyl radical. That's the first step of propagation. Then in the second step, the methyl radical will then grab more chlorine molecules and form your substituted chloromethane, plus regenerate the radical, and the radical will go back and start the step again. So a propagation is a chain reaction. So in this case, everything will be seen in the mixture. That's for question 2. Question 3, which represents incomplete combustion. If there's incomplete combustion, we will not get carbon dioxide. We will get carbon monoxide or carbon. So therefore, this is carbon dioxide. This is carbon monoxide, and this is carbon, and they are all combustion because they are burning in oxygen. So incomplete will be 2 and 3. Question is C. Answer is C. Okay, next, which substance is false? Which statement is false? Butane undergoes free radical substitution with bromine under strong sunlight. Now, it is not false, it is possible, but it is not where the double bond is. So if I have a butane, right, this part will undergo free radical, this part will undergo electrophilic addition. But because there's sun around, there's UV light around, maybe this portion here may be able to undergo free radical substitution. Okay, so I cannot say there will be totally no free radical substitution because there's still alkyl chain. So this is possible. So all homologous series of alkenes have the same empirical formula. Take note, no functional group have the same empirical formula. They usually have the same general formula, except alkenes. Alkenes is the only functional group that have the same same general formula and same empirical formula. So they have same empirical and same general. They are the only one. How do you know? You list out the alkenes, C2H4, C3H6, C4H8, and you change it to the lowest term. The lowest term is CH2, 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 and the idea of empirical formula is lowest term. So you can see all of them have the same like lowest term, which is the empirical formula. Okay, alkenes can decolorize bromine in the dark. Yes, they can, because they can do it anytime. They are so reactive, just as long as it's in the room condition, it can. Alkenes are susceptible to nucleophilic attack. Nucleophiles loves positive charge. So you all don't tell me loves nucleus, but loves positive charge. That's why it's called nucleophile, because nucleus is positively charged in a way. So therefore, alkenes are not going to attract things that loves positive charge. because alkenes are electron rich. So they will attract things that loves electrons rather than things that loves positive charge. So therefore D is wrong. Okay. Now next question 5. We just finished up all the MCQ. Question 5 over here is not an electrophilic addition. So we are not seeing things being added into the structure. So the first one is an addition. You add a HBr. Second, you also added a HBr. Okay, so how can you see you have added? You see this one from 2H, total 4H to become 5H and a Br. This total from 6H to become 7H and a Br. This one starts with a 6H, ends off with 4H. So you're not adding some, you are not adding. So you started with 6, you end up with 4. The next one, you have started with 6H, you end up with 6H. But you are adding bromine. So bromine is added. Right? So although you didn't add H, but you added bromine. Now, but for this one, let me just double check this one again. This one you started with 6H, but you did not end up with 6H. But instead you got 2Br. So what we can see is 2 of the H is actually replaced with 2Br. But at the bottom case, I have 6H. I still have 6H. Plus, I have 2 more Br. So I'm adding to it. Okay, so this one is the substitution reaction, where there is substituted hydrogen. Okay, next, which monomer will form the polymer? So remember, the monomer is this the actual thing, but now with a double bond. So we just need to name this. So the longest chain is 1, 2, 3, 4. So 4 carbon, double bond in center, so butene. So it's butene. Answer should be D. Not 1,2-dimethyl-ethene, not 1,2-dimethyl, because the longest chain is 4. Question, last one. Which of the product is likely to be formed when you react with excess liquid bromine in the dark? So in the dark, we are expecting addition reaction only. So we are having addition reaction. So we should add across the double bonds with bromine. So, and then this should be added with double bond with bromine. So I cannot still have a double bond in the structure because by right, all the double bonds should be added. So therefore, these two are out. So out of this, we just need to make sure we are adding bromine. Okay, so there should be a total of 1, 2, 3, 4, 4 bromine added in the answer. So therefore, it's E for boys. Okay, now, so we have finished the MCQ question of assignment J2. So the structure, we will continue another time. So we stop here for the recording.